Just the other day, Shenzhou 20 was struck. The culprit? A fragment smaller than 1 millimeter. It slammed into the cabin at 7.8 kilometers per second. That's 23 times faster than a bullet. Its impact carried the force of a small bomb. Luckily, the cabin was strong enough to hold. But the return of the 3 astronauts had to be postponed. And the worst part? This is only the beginning. Right now, floating 200 to 2,000 kilometers above our heads, there are about 130 million such fragments in orbit. Each one is traveling at a hypervelocity of 7 to 8 kilometers per second. According to tracking data, there are 34,000 pieces larger than 10 centimeters and 1 million more between 1 and 10 centimeters, big enough to destroy satellites outright. Then there are billions under a millimeter, so densely packed they blanket Earth's orbit like a storm of bullets. The most terrifying discovery? Scientists have confirmed that the total number of fragments has passed the critical threshold. Even if humanity stopped all launches right now, these fragments would still collide with each other, creating even more debris. This is what's known as the Kessler Effect. Once it spirals out of control, within just 50 years, Earth's orbit could become a death zone. Satellites would fail. Global communications, navigation, and weather forecasting would all collapse. Human civilization could be set back by decades. You might think a millimeter of debris is nothing. But in space, a single 5 millimeters paint chip can hit with the same energy as a car falling from a 10-story building right onto you. In 2016, a tiny fragment less than 0.5 millimeters wide struck the observation window of the International Space Station, leaving a 7 millimeters crater in the glass, a near disaster. And remember, that window has 4 layers of reinforced glass more than 3 centimeters thick. Even so, it was still dented by that microscopic projectile. And it gets even more dramatic. In 2023, the robotic arm of China's Tiangong space station was hit by a tiny fragment too. It punched a dent straight into the metal alloy. Astronauts aboard Shenzhou 17 had to perform an 8-hour spacewalk repair. So where did all these fragments come from? The answer might shock you. 90% of them were created by humans. Since the Soviet Union launched the first satellite in 1957, humans have sent more than 12,000 satellites into orbit. Less than half are still functioning. The rest? Space junk. Even worse is rocket debris. Each launch leaves behind upper stage tanks, fairings, and separators, massive chunks weighing tons, orbiting for decades before they finally fall. And the deadliest source of all? Collisions. In 2009, the first major space collision in history occurred. America's Iridium-33 satellite and Russia's defunct Cosmos 2251 crashed head-on over Siberia at 11.7 kilometers per second. The explosion created over 2,300 fragments. More than 1,500 of them are still orbiting today, a nightmare for every spacecraft. But even that wasn't the worst. Anti-satellite weapon tests made it far worse. In 2007, China destroyed one of its old weather satellites, producing more than 3,500 trackable fragments. They're still orbiting, still threatening other spacecraft. Then, in 2019, India carried out its own test, blowing up a satellite at 300 kilometers altitude. It created over 400 pieces of debris, a direct threat to the International Space Station, which had to dodge them 3 separate times. And this is how humanity explores space while turning it into a junkyard. The next question, can we clean it up? Honestly, it's almost impossible. First, you have to find the fragments. Pieces larger than 10 centimeters can barely be tracked by global radar, but centimeter or millimeter-sized ones remain invisible. And even if you spot them, How do you catch something moving 10 kilometers per second? Just adjusting a spacecraft's orbit to intercept one fragment burns tons of fuel. It's insanely expensive, and if you miss, you might just create more debris. The European Space Agency plans to launch Clean Space 1 in 2026. A mission to grab a dead satellite with a robotic arm. The cost? 120 million euros. And it can only capture one. At that pace, it would take thousands of years to clear the debris we already have. China, however, is leading the way. On October 21, 2022, a Chinese satellite successfully captured a defunct satellite and towed it to a higher graveyard. Orbit. It was a world-first achievement. Scientists have also suggested using ground-based lasers to nudge debris out of orbit, vaporizing surface material to create thrust and push them to burn up in the atmosphere. It's the most economical plan yet. But there's a catch. The same laser systems could double as space weapons. So progress has been slow, as countries remain cautious. In short, the cleanup rate can't keep up with the speed at which we're making new debris. Projects like Musk's Starlink have already launched over 5,000 satellites, with 40,000 more planned. Amazon, China, and Europe are launching their own massive constellations too. Within the next decade, the number of satellites in low Earth orbit could surpass 100,000. What does that mean? The chances of collisions will skyrocket. Once the Kessler Effect hits its tipping point, a chain reaction will begin, like falling dominoes, unstoppable. Earth's orbit could turn into a cloud of debris within just a few decades. GPS will fail. Satellite TV will disappear. Weather forecasting will collapse. Global communications will break down. And humanity's dreams of lunar bases or deep space exploration will vanish. We'll be permanently locked on Earth. This isn't science fiction. Scientists warn it could happen as soon as 2050. To prevent this, a new 5-year deorbit rule is now in effect globally, requiring all newly launched satellites to re-enter the atmosphere within 5 years after their missions end. But it only works if every nation follows the rule. If even one country ignores it, everyone pays the price. As for Shenzhou 20, although its return was delayed, it proves one thing. China's space program puts safety first. A complete backup plan is already in place. Shenzhou 21 stands by as a rescue craft, ready to launch within 8 days if needed. This emergency response system is one of a kind in the world. And the spacecraft's design itself includes multi-layered protective shielding to withstand most impacts. Still, the threat of space debris grows worse each year. This is a shared challenge for all humankind, and it demands that all nations work together. Otherwise, our children may never again see the sea of stars.